those out, please.
And I put the same, similar to going to both crush.
So they both had steam and pressure as part of it, and then the time. So you think the time is different?
I'll tell you, because the pressure was fast.
Okay, so let's go ahead and talk about this. What is similar between our pop can and the crushing tanker? Yeah, what's one thing?
Both crush.
Good, they both crush. Good, what else?
They're both metal.
They're both made of metal? Let's, do you think that the material is important? Do you think if one wasn't made of metal, it'd be different?
Yeah.
Okay, so maybe the material is important, that's similar?
Because if it was glass, it would just break.
Okay.
Boom.
Okay. What else is similar?
They both had steam.
They what?
They had steam.
They both had steam? Fabian? You're talking about this? Yeah. Okay. What else is similar?
Yeah, I wasn't really good for the. That's why I'm asking.
Oh, you were explaining it?
Yeah.
Okay. What else was similar? I'll ask somebody over here. Justin, actually, why don't you tell us what else was similar? I know you have one.
Air pressure.
Good. So, can you say more about the pressure thing?
I'm not really sure. The steam causes the air pressure.
Okay. So they both had steam, and that steam is linked to causing pressure. Why do you think steam is linked to pressure?
Because, I don't know, it just does for yesterday's experiment.
Okay.
Yeah.
Does anybody have something that could, yeah?
Because it's a gas, and gases don't really like to be contained.
Okay, and so what does that have to do with pressure?
They probably were pushing outward, causing more pressure on the can.
Okay. And do you think that was similar inside the tanker?
Yeah.
Okay. What else is similar between the can and the tanker? Anything else? What about differences?
They both started with gas and then
They both started with gas and ended up with liquid. Do we know that that's what happened in the tanker, or you're just, that's what you think was happening in both? Okay, so we think that the same thing was happening in both. We couldn't see inside that tanker, but we can kind of think that they're similar in that way. What else?
I think timing could be different too.
Okay, tell me more
Timing,
about that.
because since I wasn't here yesterday, did you guys time the pop can when you popped it?
Did anybody time how long their pop can took to crush?
As soon as it touched the water.
Okay, so it seemed like it was as soon as it crushed the water.
Yeah, and like the size of the tanker was bigger than the can, so it probably took more time for the tank to crush rather than the can. This one's smaller.
So maybe the size of it will affect how quickly it crushes?
Yeah.
Okay. What else? What else is different? Temperature? What's different between that?
They both needed cold.
What's that?
They both needed something cold.
Okay, so that was similar. There was a change in temperature.
Yeah.
What's different about how the temperature changed for the two things?
The pop can was heated on a hot plate, and the tanker, we don't know if it was heated up or not. It was just outside.
Okay. What's our story about how the tanker, what did they do to the tanker?
They steam cleaned it and then sealed it off.
Okay, so if there's steam cleaning it, then what could you assume about the temperature inside?
It was hard.
Okay. But you're right, the way that it was heated is different, and the way that it was cooled off is different, right? Okay, any other differences you can think of?
The can wasn't sealed when we were heating it.
Okay, so it wasn't sealed when we were heating it. I don't know how tankers are steam cleaned. Do you think it was sealed when they were heating it?
But there was probably steam still in it when it was sealed.
Oh, okay. So that's another good thing to think about. So yesterday, you started making some questions about what you think affects how much the can crushes, and we've already started talking about that. Fabian already said an idea, and I think Rick is kind of getting an idea here about maybe some differences, what might affect how much the can crushes. So if you can get out your worksheet from yesterday, you made some statements like this. I think something might affect how much the can crushes because I want you to take a second to look over those. I want us to come up with ideas to experiment with today. So we're going to take these, and each group is going to test one of these differences. So we come up with a big picture of what affects how much this can is crushing. Okay, so what's one thing that you think could affect how much the can crushes or affect that gas inside the can? Okay, the amount of water. So can you tell us it in this form? You think the amount of water?
I think the amount of water in the can might affect the way that the can crushes, because if we use more water, it might have crushed differently, maybe slower, faster, or might not have crushed at all,
Okay, and why?
because we don't know.
So if I have a can and it has half full of water, a little bit of water, and full of water, and I heat those all up,
It's gonna take longer for the most amount of water to heat up, and it might cause like a problem with the steam, like maybe you'll have less steam or a lot more steam, cause it to crush quicker or slower maybe.
okay, so the amount of water in the can might affect the amount of the can crushes because the amount of steam would be different?
Yeah.
Anything else? Okay, amount of steam. And how quick, you said how quickly it took to, and how long it takes to heat up. How long it takes to get the steam. Some more of you wondered about this amount of water in the can yesterday, and you had another idea of why it might affect how much the can crushes. So what's another reason different amounts of water in the can might affect it? I think some of you talked about this.
Maybe it can't crush because there's so much water that it can't push. Yeah, it can't compress.
Okay, so water can't compress as much as steam. So if you have more water, maybe that would cause it not to crush as much. Okay, good. So this is one thing. Can we think of another one? What's another idea you have of what might affect how much the can crushes? So can you tell us in this statement, I think
that the water, how cold the water might affect the can should be crushed.
because
Because it would have like a more, I don't know.
more what? You're on a good track here. More, it might cause, what might that difference in temperature cause? If I take my water bath that I'm about to put my can in here, and that's ice cold, and then maybe there's another one that's not as cold, and maybe one that's warm, how do you think that might affect how much the can crushes?
I don't think it'd crush as much if it was warm water because it's just the same as it's almost like the same temperature as the inside of the can because it's not as cold, it's just warm. And I think maybe it's the coldness of it that makes it crush.
Okay, so we talked about yesterday, we said here, when we were talking about the tanker, temperature affected the molecules. So let's link that to this, the temperature of the water bath. What would changing the temperature affect it? Or why would it? We talked about this yesterday, about temperature affecting the molecules inside that tanker, the temperature change. So how could this different amount of temperature, a different type of water bath that you're putting in, affect your can?
If it was colder, it might crush it like quicker or crush it more, maybe because the coldness would slow the molecules down a lot faster.
Okay. Rika, what do you think about that?
I think that, like, basically what she's saying is right. If you put it in warm water, it might not crush as much as it would if you put it in ice water because it's just warm. It's not really a drastic change in temperature.
Okay, and how does that affect the molecules?
Maybe it slows them down a little bit, but not a lot.
And I want you to keep trying to connect the movement of those molecules to the what's keeping the can either crushed or not crushed. So the temperature change isn't as much, so the molecules don't slow down as quickly. So I guess there's a few things you could measure here. You could measure how much it crushes or how long it took to crush. Because I heard you say that it might take longer. I think you said that, and you said it might not crush as much. Okay. What else could we test? So we can change the amount of water we put in the can. We can change the temperature of the water bath. Justin, could you talk a little bit about what you guys noticed yesterday when you were heating up your can? And okay, so say more about that steam.
When it reached the cold water, it probably pulled it together to crush it.
Okay. And do you think the amount of time that you heated your can affected your results?
I think so. I think because we boiled it more than other
Okay.
groups.
So you think you boiled it more than other groups, and do you think you got a different result than other groups?
I don't know about the others, but I think ours crushed more.
Okay, so let's say Justin thinks, I think that boiling, the amount of time that I boil the steam might affect how much the can crushes because? Why do you think it might affect it more?
Because
Is this hotter?
or more steam.
Okay, so the amount of time on the hot plate might affect how much it crushes because it creates more steam. And why is that important?
The more steam, the more it'll crush.
Why?
Because, well, it has to do with steam. Just like the tanker don't have steam, that's why it crushed though. So I guess the more steam, it'll crush.
Okay, and I heard you say something yesterday about the air that was in the can. And when you heated it up more, what did you think was happening?
Taking out most of the air out.
Okay, so maybe if you heated it up more, it creates more steam, pushes out some of that kind of regular air. And why would that cause more crushing, do you think? Why might more steam versus air cause more crushing?
Less pressure.
Less pressure where?
Because when air is keeping the can to not crush, so when you put the steam into and turn it upside down into the cold water, it brings all the steam out into, like, pulls it down to the cold water, causing it to crush.
Okay, so something about the steam is able to become water. And so, do you think if you were just cooling down that air in a can, that would become liquid, the liquid form of air?
Yeah.
Versus the liquid, you know how steam is a gas and it becomes a liquid? Does air, if you cooled it down, does that become a liquid as quickly?
No.
Okay, so that's something to think about here. Can you think of anything more to test? We have 3. I would like to get 5 different experiments we could do. Barbie, let's think about your idea about how big or how much, how big the tanker is or that volume. And what do you think about the size of a can? So over there you see I brought in a couple small cans and a couple big cans. How might the size of a can affect it?
Probably since the size of the cans are small, it'll take less time for the steam to get to all the around the can, inside the can.
Okay,
And
so
the tanker, since it's big, it takes more time to reach all of the parts of the tanker.
okay, and so if the tanker or the can is bigger, so I'm going to write this here, size of object or... So the size of the object, and what do I mean by size? Because we're talking about like the 3-dimensional size inside, so I'm going to change this to the volume or how much space is available.
Yeah.
So the volume of the object might affect how quickly, you said how quickly the can crushes?
Yeah.
Because?
Because it takes more space, or less space for the can to steam to reach the whole can.
Okay, so the amount of filling, maybe? Filling with steam. The space available for that steam to fill up when you're heating it or when you're turning it over is different. Okay, I want us filling with steam takes longer. What about That's for, I think you're talking about for the heating part. What about when we flip it over and try to cool it? What do you think would be the difference based on the size of that can?
I think it'll take less time.
Less time to crush what? The smaller one or the bigger one?
The bigger one.
Less time to crush the bigger one because? What does somebody else think? What do you think about that, Johnson? If we have a small can and a big can, which one might take longer to crush?
I think would be big can or
Small can.
So which one did you say, Johnson?
big can. He said big can.
Big can? You think that would crush which? Quicker or slower? Or more or less?
Slower.
The big can would crush slower because?
Because the big can has more space for the seed to get fill.
Okay. And what would that have to do with crushing?
It'll take longer for it to crush or to boil or.
Okay, so it may take longer to fill that can with steam, but then what about when we flip it over?
Take longer to crush it.
Why?
Because there's more. Yeah.
Okay, so filling with the steam takes longer and maybe crushing. So if we're talking about the big can, crushing would also take longer or be less because there's more steam, and that more steam would take longer to cool down. And I think another thing that some of you were puzzling about yesterday was, do I have to flip the can over into the water? Does sealing it matter?
Yeah.
Was anybody thinking about that
If you're
yesterday?
worried about the water's going to destroy.
Okay, so let's think about that one. I think if whether or not the can is sealed, when I flip it over, might affect how much it crushes because. Can anybody take a guess at that one?
The steam comes out?
So what?
The steam comes out?
Okay, so Javier is saying if I take this can and I just take it off the hot plate and put it in the.
Like if it was sealed and you were to boil it in there, then it'd have way more steam.
Okay, so there might be more steam. So if you could heat it, if it was sealed, it might keep the steam in it. But what if you could heat it while it's open and then you just take it off the hot plate and put it in the.
Probably wouldn't heat the temperature, or probably wouldn't cool down the temperature inside as fast.
Why not?
Since there's no open hole for the cool water to get in.
Okay. So I think that one, when you're doing your experiments today, I'd like you to have 3 different conditions that you test. So one example would be if you're going to test how much water you put in the can, I want you to test 3 different amounts. And I don't know if the sealing the top of the can, if we can have 3 different ways to do that. So how about if our 5th experiment is...
what happened you flipped it like upside down?
So upside down?
Yeah,
Upside down or right
I
side
mean,
up?
not the drinking part, but the bottom part. Like, put it in there. with the
Okay, so I
bottom.
have a can and you're saying either put it
Yeah, like that, like it's standing up right now. Yeah.
this,
Yeah, I want to see. Like,
this,
what
or what?
The
What's our
first one.
third?
Sideways.
On the side.
So just kind of sideways?
Yeah.
And how's that affecting, if I put it in sideways, how's that affecting how much it's sealed?
Because maybe a little will go into the top, and then
Maybe half of it.
hopefully it pop up. I just want to see it pop up.
Okay, so maybe half of it, if I put it in water, the water might cover half of it?
Yeah.
Yeah.
Okay, I'm not sure if that will work, but you can give it a try. So, does the amount of, what can I call it, sealing? Amount of how much it's sealed?
Oh, it's good information.
I'm going to call it sealing for now. And we say yes or no, will it affect it?
No, I don't think so.
So we think, some people think it will affect it, so Rika, tell us why. Because?
Because if it's sealed, it'll probably crush, but if it's not sealed, it probably won't get as cold as quick because there's no cold water going into it. It's just surrounding it.
Well, I know cold water going to it anyway.
But what if, so
I know there's no cold water going into it.
if I take
If
this,
everything there upside down, maybe there's some going in.
I don't want to argue.
if I take this and it's halfway full and put it in, or if I put it this way and it's halfway full, the same amount of water, cold water, is touching it. So we're thinking only about how does closing this can affect whether or not it crushes.
There'll be probably more steam inside of it.
Because if it's this way, steam can keep coming out?
Yeah.
Okay, so why could that affect how much it was gonna crush or not crush?
Maybe if there's more steam inside of it, it'll crush more or less because the steam affects the pressure of the can.
Okay, so something about pressure from the steam being kept inside. All right, and then also that we have to keep in mind that there's a temperature change going on here. So what I need now is for your groups to decide which one's going to do which experiment. So is there a group that's going to volunteer to do number 1?
2 minutes.
2 minutes?
2 minutes once it starts boiling, or just 2 minutes?
No, we're waiting for it to get warm and hot, like, and then we're gonna push it and start 2 minutes. And then we're
Okay.
gonna put it 15 millimeters and then do it 4 minutes.
Okay, and then,
Up to 6 minutes.
okay, so 2, 4, and 6.
Yeah.
Okay, and which one do you think is going to crush more?
I think it will be the 6 minutes because it's longer. It's boiling longer.
Okay, and what does that have to do with how much it would crush?
How much steam it is, or how much steam is in the can.
And when you flip it over then, why would the one with more steam crush more?
Crush more
More
last.
steam it has, it'll crush more because you have like no space out there or anything.
Okay, so it's only steam in there. And what happens when you put it in that cold water? What happens to the steam in the cold water?
It'll interact with the cold water.
It turns into molecules.
Of what?
Maybe.
So with the steam, we have water in here, you heat it up and it gets filled with steam vapor.
Yeah.
Then you flip it back over into here, and what happens to that steam vapor?
It cools down. The molecules are not moving fast.
They're not moving as fast, and what happens to them then?
They all the way at the bottom of the can.
And are they still in the form of steam?
No,
What are they?
they're in the form of water.
Okay.
They turn into water.
So
They're
something
too bad.
about how much steam is in here, and then that steam, when you flip it over, turning it into water. How does that? I want you to think about how that affects it. Affects how much crushing you get.
Right?
America, I hope you guys watching.
Did it ever boil?
Oh, there we go. Told you that was fire. So
It's not that
So,
cold.
yeah, cause it didn't.
If it was colder yesterday.
Cause yesterday it popped like it was
I
nutty.
know.
It did too though.
Our water's not that cold, so that's what happens when it's not that cold.
Okay, so we want to make sure that when you try your next one, this was the one that you flipped it over. You're going to compare it to this one. So you're going to see which one crushes the most
Smart
Based.
idea, Vernon.
on this water. So it's important, yeah, not to compare it to yesterday, because if you think the temperature of the water bath isn't making a difference, then
Well, we getting cold. Let's go.
I did. What do you think, Peter?
But you never know.
Right. I don't know. I'll probably crush longer because it's like it doesn't touch the water or steam inside when it's face down.
I think all the steam will just like rush out the top and it'll crush a little bit.
That'd be 50. I think that one's gonna like. I think it's gonna pop out the water, do a 360, dump back in the water.
A couple of ollies here. and
Yeah,
there.
come on, Ali's. Give me a handshake, back in the water. We should.
So we could
Well, we
have
should
them
like
exactly.
increase everyone by 1 minute. Like start
But
off
then
like
we'd be
2
changing
minutes.
time instead of changing the way that we put it in there. So we'd have to put them
Good
all in there
thinking.
the same
Oh,
way.
good thinking. Good thinking.
Yeah.
This what happens when we set it down.
Nothing.
It farted. You didn't see a little bubble? So for procedure, put it farts.
That's not right there. Fart.
That'd be funny though. Alright. Come on, we got time for this item.
I should have had you take a video of this with your cell phone.
That would be funny.
So you just watch it over tomorrow instead of writing everything
Look, it
down.
did fart. Like, look at the bubble. It did.
We put it in there just like
little
that,
bubble
and a
came
little
under.
bubble came up
like a bubble came out of the can.
Came
from
out.
the bottom. It was like you put it in the water.
She
and
said out of the can. Like, then no steam. I thought some steam would come out. But then
Well, the steam did come out, but not as fast as I
Not as
thought it
fast.
would.
And then
But
it said,
ain't really do nothing. And it was like bubble,
then it said,
bubble.
whoop. Oh, you seen
Well,
Finding Nemo?
Because look at the bottom of your can here. So what do you think's happening if you put
I
it
think because like
in there?
basically like there's no way you can get a little bit of water in there, so therefore it reacted differently.
Okay, we'll talk more about that tomorrow. But did the can crush at all?
No, not at all.
Okay.
Here, it did.
No, it didn't.
So we got time to do this one?
No, we're gonna.
We might go.
Yeah, you can finish yours. Okay, so you're gonna start by explaining what you think is gonna happen when you have your different temperatures. So Hosen says he thinks it's gonna be a different amount of crushing. Why? In this one?
Yeah, this one is gonna less
Crush less? Why?
because it's not cold.
Because it's not cold?
It's not colder than ice.
So it's not as cold as the ice water, and so why would that make it crush less?
Because maybe it's not in the
Maybe it needs to be cold to
the water is not
crush it.
Why?
Because it feels, because it's probably, it's cold, increase the speed to crush it faster. But if the water is not as cold, then it'll probably take longer to crush.
Okay, and so what does temperature have to do with speed?
I don't know.
If it's colder, or so if I increase the temperature, what happens to the speed of the molecules? If I raise the temperature?
Oh, then it'll move faster.
Okay. So think about how those speeds of those molecules inside your can might affect it.
If it feels colder, it take longer since it's colder. When molecules are colder, it doesn't move as fast.
When it's
and
colder,
when
it
it's
takes
heating
longer
up-
to slow the molecules.
When the water is, the colder the water, the longer it will take to crush.
I think, is that right? I don't know what happened yesterday, so I don't know.
No, I think it's more crushing.
More crushing if the water's colder? Why?
Oh, that's how it is? Okay.
They don't know. Yesterday they just did it in some cold water.
We'll figure out right here.
No, you have to make a prediction first. It's not
Yeah, no,
figure it out and
that's
make
a prediction. That's a
Okay.
Probably, because it has a lot more space to fill.
Yep. That one sounded like it took a long time for it to do that.
Yeah, it wasn't immediate.
It was like, okay. So why do you think that they did that?
They didn't put like enough water.
There's more space for, there's more volume of steam to cool down.
Okay.
I say if we put more water in there, it would have crushed faster.
Okay, so you think that because, so let's think about what you did have instead of what you didn't have to start with. You had just 15 down here, milliliters down here at the bottom, and you heated it up, and so Tanya, why do you think that adding more water would help?
Because like, if there's too much space for it, like, there's not enough water.
No, I just
realized it's bigger.
Okay.
More steam, more water in it. Yeah, and if we took up more space.
So Tanya said there's too much space for how much steam is in there, and so what does that have to do with the like pressure inside the can or
It
pressure?
takes longer to move it.
There wasn't enough pressure
There's maybe not as much pressure because why?
because there's more space to fill up.
More air. There is steam.
Okay, so maybe because there's more space, it's less pressure because
The ratio between the space and the pressure.
interesting idea. I want you to keep thinking about that, see if that holds true for your other two cans.